The years we have used Google Translator off and on. Now more and more people are using it in different contexts. So how has Google Translator evolved over a period of 14 years? We will look at that with one example. And yes, the picture on the left is me without a PhD, and the picture on the right is me with a PhD. Approximately 30 years apart. Before I get into Google Translator and so on, let me first briefly introduce what the first machine translator demo was, which was given on the 7th of January 1954. It was called the Georgetown IBM System 701. And the demo was basically what we will today call a nothing burger or a vaporware. And the newspaper reports were absolutely breathless about what it said. For example, the New York Times said it was the electronic brain that translates Russian. Washington Post says the bilingual machine. Other newspapers went on to say it's the robot brain translate Russian into King's English. Some called it the polyglot brainchild. In reality, it was very, very modest. It had a vocabulary of 250 words, where it translated, presumably, the Russian words into English words. It was fraught with problems because, as we know, the same word can mean lots of different things in different languages. And not only that, different words in the same language can also mean the same thing. And so basically this was able to translate about 47 sentences from Russian to English once it stripped off all the verbs and so on. So the basic idea was to, during the Cold War, it wanted machines to understand what's going on in real time. In reality, it was none of that. Fast forward to 2009. So here is a Chinese sentence where the first one you can all read is a number, the year 1519, and the second word in Chinese says year. And the one that is highlighted in Chinese in red is the word for Spain. And the next word, which looks like somebody is doing a namaste, which is actually Chinese to mean people. So essentially, it says those four characters say Spain people or Spaniards. The reason why I'm explaining all of that is because if you do a count of all the characters that appear in Mandarin, there's a lot more of them than what appears in English at the bottom. And that's because a lot of these words are shorthands which are common in European languages such as English, which is not common in Mandarin. And that's why it takes four different characters to say Spaniard. And that's why the Chinese sentence is much, much longer. And this is to highlight the problem that when we translate from one language to the other, we have to accommodate all these intricacies of two different languages simultaneously. So the first sentence here is in Mandarin, as I said, The second sentence is the same thing, but now translated by human translators who obviously take into account the nuances of the language. Notice that the second sentence says they lost 2/3 of their soldiers in the first clash. Now there the word they is not very clear. Does that refer to the Spaniards or does that refer to the Aztecs? There is another problem with this sentence, and that has to do with historical fact. It may sound like this sentence is saying basically 600 Spaniards came in and defeated the big Aztec Empire army. The reality is far, far from the truth. The reality is the Spaniards made an alliance with another group of people from Tlaxcala who were actually had a bigger empire than the Aztec Empire at the time. And they pretty much surrounded the entire Mexico City, and they have been fighting the Aztecs for years and years and years, long before the Spaniards came into the picture. So what the Spaniards did was, with the Tlaxcala people, it made an alliance and then attacked the Aztec Empire, and thereby conquering the Aztec Empire. So it was a much more complicated fact than what this simple sentence says. So every sentence that we translate, similar to translating a picture or something like that, we want the ground truth, and we want the translated version to see how the ground truth differs from the translated version. So in 2009, this sentence at the top in black, recall that's the English translation of the original Chinese done by humans. And the second one was how 2009 Google Translator translated it. It said 1519 with a space, 600 Spaniards. So there is nothing, qualifying. For example, the 1519 refers to the year of 1519, and 600 refers to the soldiers that came in. And if you notice, they're pretty awkward translation. 2013, we are looking at the same thing. Again, there is not a whole lot of improvement on the translation that you see, except that now the translator is confused between hundreds of millions of people. There were no hundreds of millions of people anywhere. And so this translation is more confused than it was. It's more rich, slightly more rich in words, but not more illuminating. This one says very clearly that the one in blue is the translated part. It clearly says that the loss that they're referring to, in the first one, recall they said they lost. Now it says 2/3 of the loss of soldiers, referring presumably to not the Spaniards, but the Aztecs. Now this is a translation I did today. So it's 2023 version of Google that's translating all of this. And you see now it is fairly close to what the original sentence was, at least the English translation by humans are. So what has happened in the meantime between, say, 2015 and 2023 is that the basis of the language translator has changed. It was using convolutional neural network to do the translation in 2015. Now it's a different story altogether. And therefore, the translators have become much, much better at translating things, as you see in a different context for the ChatGPT version of today that uses GPT-3 versus the corresponding GPT-1 that was used earlier, 6-7 years earlier. When I say machine translation has come a long way, what exactly do I mean by that? What I mean by that is the following. Earlier, meaning from the 1990s to early 2010s, people were using what is called the statistical machine translation. So the core idea is you have a probabilistic model that you start with the data and then you convert that into some other language from one language to another. So essentially it's a Bayes theorem based rule which given language X, you try to maximize the probability of Y is the other one, using Bayes argument. Now, what has happened that statistical machine language translation is a huge research field, but it got very, very complex. Now, what has changed in the past few years is that it has been substituted by what we call the NMT, or the Neural Machine Translator. So what it does is does a machine translation with a single end-to-end neural network, which involves sequences and two recurrent neural networks in order for it to function. And that has simplified the process by a huge margin. I will have another talk on that later on.